So this one is the PLC controller. The controller having some different number of input ports and output ports. The input ports are represented by X0, X1, X2, X3, X4, X5, X6, X7. And the output ports of the controller numbering by represented by Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. The output ports Y0, Y1 and Y2 are directly connected with the star contactor, delta contactor and main contactor respectively. Similarly, the input ports are connected with two different terminals of the switches, that first one is start switch, second one is stop switch. Start switch 11-12, stop switch 11-12, start switch 13-14. 24 volts supply is given to the controllers. Then by using this controller we are starting the motors by star delta motor starters. This is the main motor which having the three terminals are W1, V1, U1 and the output terminals are V2, U2, W2. And these are the different contactor switches. L1, L2, L3 are different terminals of line voltage. This one is the neutral lines. And then this one is delta connection point. In that case, the output terminals are connected to the different terminals, the terminals of the motor, and the input terminals are connected to the input points, input supply terminals of the motors, that is at the point L1, L2 and L3. Then PLC ladder logic. This is star delta motor starter ladder logic. How the PLC ladder logic is applied to the star delta motor for starting purposes. So this one is the start motor main contactor 1. This is one is main contactor 2. Main contactor 1. This one is main contactor 2, represented by Q1 and Q2. This is the start terminals represented by I1, stop terminal represented by I2, overload relay terminals represented by I3, main contactor represented by Q1. Similarly, this point also another main contactor is there, star to delta times, that is T001 T1, delta contactor Q3, star contactor Q2. This one is the controller, a timing setting multiplier system, TSM system is there, that is start to delta time T001 to T1. This is the main contactor, start to delta time T001 to T1, star contactor Q2, delta contactor Q3. So there are different contactors are connection here, and this one shows the star delta motor starter by using ladder logic. This one is one ladder, this is number 2 ladder, this is number 3 ladders. Number 1 ladder comprises of start switch represented by I1, stop switch represented by I2, overload relay represented by I3, main contactor represented by Q1. This is main contactor Q1 also shunted with the start switch. Then second ladder, that is also another contactor is there, that is also main contactor Q1, then start to delta timing, that is T001 T1, delta conductor Q3 variable in nature, star conductor Q2 is variable in nature. So this one is start to delta time, that is T001 T1. Third one is the main contactor, that is Q1, start to delta time T001 T1, star contactor Q2, delta contactor Q3. So there are three different ladder lines are there. This one is the main bus lines, this one is another bus lines. This ring 1 main contactors. The main contactor depends upon the normally open output input start push button I1. Normally close stop bottom I2 and normally closed overload relay. It means that the main contactor will only be energized if start button is pressed, while stop it not pressed and overload relay is not activated. A normally open input named Q1 is added in parallel to the start button I1. By doing so, a push button is created, which means that once the motor is started, it will be kept started even if start button is released. Next, ring 2 of the star contactor. The star contactor depends upon main contactor. Normally, close contacts of timer T1 and normally close contacts of output delta contactor Q3. So, star contactor will only be energized if main contactor is on. Time output is not activated and delta contactor is not energized. Timer T1, that is the function of timer T1 here. The timer T1 measures the time after which the winding connection of star delta starter is to be changed. It will start counting time after main contactor is energized. Ring 3, that is delta contactor. The delta contactor will be energized when main contactor Q1 is energized. Timer T1 is activated and star contactor Q3 is de-energized. Next, develop a ladder program for DOL starter. So, working of DOL starter or direct online starter. The one method of starting electric motor is using direct online DOL or across the line starter. In this method, full line voltage is applied to the motor terminals. This is simplest type of motor starter. An electrical wiring diagram for single phase dual starter is shown. This one is the control program of the control circuit for DOL starter. This is a overload relay switch connected to the phase. This one is the single line diagram which comprises of fuse, stop PB, start PB, that is push button switch stop, push button switch start. This is the two of relay or contactor relay contact. This is contactor or relay. This one is the neutral line, this one is the phase. So this is the single diagram for control circuit for DOL starter. Repeat again, this is phase, that is overload relay switch. This one is fuse, that is stop, push button switch, start, push button switch, relay, contactor contact, contactor relay. This one is the neutral switch. So control circuit for DOL starter. A dual motor starter contains fuse and overload relay OLR for protection purpose. The starter can be contained momentary contact or maintain contact push buttons. The example consider here is momentary contact push buttons. For starting purpose, normally open NO push button is preferred, whereas normally close push button NC is used to stop the motor. The excessive supply voltage drop causing high inrush current is the criteria to limit the use of DOL starter. Conveyor motor, water pumps are the applications where DOL starters are used.